Okay, today I'm going to explain the trig sheet and how to create it and how to use it. So this is a sheet that Miss Welsh created for us, and it shows our unit circle divided up into our most commonly used angles: pi over 6, pi over 4, pi over 3, pi over 2, and it talks about where sine, cosine, and tangent are positive and negative. Okay. Now, the way I remember it to help me keep track is I associate y with sine and cosine with x. So if you think of the Cartesian coordinate plane, where y is positive, sine will be positive, and where y is negative, sine will be negative. And if you think about where x is positive, cosine will be positive, and if you think about where x is negative, cosine will be negative. And then tangent is just sine over cosine. So when sine and cosine both have the same sign, then our tangent will be positive. And if they have alternate signs, tangent will be negative. And then secant, cosecant, and cotangent are exactly the same signs as sine, cosine, and tangent with their respective. So secant will be 1 over sine, or 1 over cosine. Cosecant is 1 over sine, and cotangent is 1 over tangent. Okay? So what we're going to learn now is how to create this trig sheet and our set of values for the common angles. So first thing I want to do is show you a quick method to learn the angles. And I'm not a fan of memorization. I'm not very good at memorization, but I can memorize one piece of information, and then I try to derive all the other pieces of information from that one. So what I do is I create this little table. 1, 2, 3, 4, and then I go 4, 3, 2, 1, 0, and I put a big square root around this. This is all symbols: sine, cosine, all this divided by 2, and then I put my angles up here: 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay? So this is pretty easy to remember how to create this little cheat here. Now what we need to know is how to use this. So instead of memorizing this big table down here at the bottom, I just memorize this one little picture here, and then I learned how to use this to find all the other pieces of information. So what I want to show you is sine of pi over 6. So I look for sine, I go to pi over 6, and what that tells me is that sine of pi over 6 is radical 1 over 2. And then I simplify this. Radical 1 is just 1, so I get 1/2. Okay? Now I want to try cosine of pi over 6. And I find cosine. I go to pi over 6. Well, that's radical 3 over 2. So this radical here covers for everything on the top, and the 2 is in the denominator. So cosine of pi over 6 is radical 3 over 2. Let's try cosine of pi over 3. So I go across cosine, come to the angle pi over 3, and that shows me radical 1 over 2. And then if we try sine, this reduces to 1 over 2. Okay? And if we try sine of pi over 3, go across here, so it's radical 3 over 2. Okay? Let's try tangent. This one involves just a little bit more work, but I'll show you how to make this a little bit simpler. So tangent of pi over 3. Well, tangent we know is sine over cosine, same angle. So sine of pi over 3 over cosine of pi over 3 is tangent of pi over 3. So now I can just find these individually. Sine of pi over 3, we said that was radical 3 over 2. And cosine of pi over 3, we said was 1/2. And then when I divide fractions, I invert and multiply. So this is radical 3 over 2 times 2 over 1. 2's go away. I get radical 3 over 1, which is just radical 3. Okay? And if we think about this, anytime, no matter what angle we pick up here, when we do tangent, we're going to get the same thing happen when we invert multiply. The 2's are going to cancel. So the shortcut here is just whenever you do tangent, you just look, like if I want tangent of pi over 3, I just do sine of pi over 3, which is radical 3 over 2, but I leave off the 2. I just do radical 3 over radical 1. Okay? And if I want to know tangent of pi over 6, I would do radical 1 over radical 3. And the same thing applies for cotangent, which we're going to look at this in just a minute. So let's try cosecant. So cosecant, we said, of, let's do pi over 6. Cosecant is equal to 1 over sine. Okay, so cosecant of pi over 6 is equal to 1 over sine of pi over 6. And an easy way to memorize this is C and S. These are opposite. So cosecant is 1 over sine, and secant would be 1 over cosine. Do the opposite letters. So this one starts with a C, so the answer is with an S. And the other one starts with an S, and the answer would be with C. So let's try this. 1 over sine of pi over 6. So sine of pi over 6 is radical 1 over 2. So I get 1 over radical 1 over 2. And then we invert multiply this. Radical 1 is just 1. We invert multiply, and we get 2. Okay. Let's try secant of pi over 6. We said secant is just 1 over cosine. Again, notice this one starts with an S, starts with a C, pi over 6. Okay, and we look up cosine. Pi over 6 is radical 3 over 2. Invert multiply, I get 2 over radical 3. But I need to rationalize this, so we get 2 radical 3 over 3. Okay. Let's try cotangent. So we have cotangent of pi over 6 is equal to, we said this was 1 over tangent of pi over 6. But tangent is sine pi over 6 over cosine of pi over 6. This is in the denominator. And then I invert multiply this, I get cosine of pi over 6 is equal to, or cosine of pi over 6 divided by sine of pi over 6. So cotangent pi over 6 is equal to cosine pi over 6 over sine pi over 6. Okay? So then I just find these individually. Cosine of pi over 6 is radical 3 over 2. Sine of pi over 6 is radical 1 over 2. Invert multiply, we notice that the 2's will cancel, so I get radical 3 over radical 1, which is just radical 3. Again, when you do tangent or cotangent, the shortcut is just don't write the divide by 2. And these will, the 2's will cancel out, so you can just do what's inside the radicals and then simplify and rationalize as you need. Okay. Now let's try angles that are in different quadrants. So if we look at our unit circle here, pi over 4 can also be found over here, can be found over here, and found here. So this is 1 pi over 4. This would be 2 pi over 4. This would be 3 pi over 4, 4 pi over 4, 5 pi over 4. So if I want to know what sine of 5 pi over 4 is, well, let's write that down. So sine of 5 pi over 4. The first thing you should do is look to see if this simplifies. Okay, this doesn't simplify, and so I see that it's a 4 down here, so I'm counting by 4. So really, this is just pi over 4. But then I need to apply the sign that's associated with sine in quadrant 3. So let's find sine of pi over 4. This is our first step, is to find sine of pi over 4. That is radical 2 over 2. Okay. Then I look here, and I find out, is sine positive or negative? Well, in quadrant 3, sine is negative. So then sine of 5 pi over 4 is equal to negative radical 2 over 2. So I want to just stress again that all the solutions that we have in this quadrant are exactly the same solutions in these quadrants, except they differ by the sign, either positive or negative. Okay? Let's try another one. Let's do sine of 2 pi over 3. Okay. Well, this doesn't simplify anymore, so this is just pi over 3. So we find out what sine of pi over 3 is, and that would be radical 3 over 2. Now we got to figure out what quadrant this is in. So I look at think about my unit circle here. This is pi over 3. All the way to here would be 2 pi over 3. So we're in quadrant 2, and sine is positive in quadrant 2. So this is just radical 3 over 2. Okay. Let's try cosine. Let me write this on a new sheet of paper. So cosine of 5 pi over 6. 5 pi over 6. Well, this doesn't simplify, so what I need to find is just pi over 6. So cosine of pi over 6 will be radical 3 over 2. So this is going to equal radical 3 over 2. And then I need to figure out what quadrant 5 pi over 6 is in. So we look here. We have 1 pi over 6. This would be 2 pi over 6. This would be 3, 4, 5. That would be right here. That's in quadrant 2. And cosine is negative in quadrant 2. So we have negative radical 3 over 2. Now, if you don't always have the unit circle available, you can always draw it down and break up these into their individual pi wedges. Or you can just think, if this was actually 6 pi over 6, that would reduce to just pi. So I'm just a little bit shy, actually pi over 6 shy of being at pi. So I go to find pi here, and I know that I'm back this way just a little bit, pi over 6 back. Okay, so then that'll help me find what quadrant I'm in. If I'm looking for, let's say, 11 pi over 6, well, 12 pi over 6 would be here, so then 11 pi over 6 would be just a little bit short of that. That'd be back here in quadrant 4. Okay. And one last thing I'm going to show you is tangent of pi. So let's do tangent pi. Okay. Well, this is equal to sine pi over cosine pi. And sine pi, pi would be here. Sine pi is 0, radical 0 over 2. And remember I said when we do tangent or cotangent, we don't have to do the divide by 2. So it's just radical 0 over radical 4, which is just 0. So tangent of pi is 0. Now let's try tangent of pi over 2. Well, that's equal to sine pi over 2 divided by cosine pi over 2. And sine of pi over 2 would be radical 4 over 2. So that's just, we just do the top, so that's radical 4, divided by cosine of pi over 2, which is radical 0. And then we see that we have a divide by 0 here, so this is not possible. We can say no solution, no real solution, does not exist, that sort of thing. But on our trig sheet, when we fill it in, you'll just put an X, not defined. Okay. Let's try one last thing, cosine of pi. Well, cosine of pi, that's this angle here, so that's radical 4 over 2, which is just 2 divided by 2, which is just 1. But cosine, we said, is associated with the x-axis. So wherever x is negative, cosine is negative. And we see that pi falls over here on this side of the y-axis, which is the negative side. So this would be negative. Cosine would be negative here, so negative 1. Okay, well, I hope this helped you. If you can always replay this to figure if anything went too fast, and practice drawing your little cheat here and practice filling in your trig sheet. Thank you.